Hi everyone. So I'm going to actually do these questions right here, but the reason why I wanted you to look at this screencast first is I think this was the last question, and I'm going to add a question here. The question here is consider the differential equation, this. And by the way, you know what? A differential equation, you want to know what a differential equation is? A differential equation is just an equation that involves derivatives. How about that? So that's what a differential equation is. A differential equation is an equation that involves derivatives. Let y equals f of x be the particular solution to the differential equation that passes through 1, 0. Okay? I'm going to add part C. And part C is to find d squared y by dx squared in terms of x and y. Okay? That's why I wanted you to look at this first, because I wanted to add on a part C to this question. Now, I will say this. Let y equals f of x be the particular solution. What that means is there was some function whose dy dx, after I differentiated this with respect to x, is this. Okay? This language here is a little bit formal, and I can't get into it quite yet because we haven't gotten to that topic yet. Actually, you won't get to this until next year. But all this means, and I think you probably intuit it, is that, there is some function for which dy dx is this. And you don't know what the function is. Okay? All right. That's all I wanted to tell you. I wanted you to add part C to this question, and what I'm going to do right here is just start working the solutions out for these here. Now, they're probably in a different order than they are in your packet, but you should know what you're doing, okay? So I'm just going to do the solutions, and you can just check with me. Okay, hi everyone. So here are the solutions. Here's this one. For that first question, you really don't need this purple line yet, the question about the areas, okay? And here is my answer to A, B, and C. Notice how succinct, right? Really succinct. Pencil's not vomiting. Pencil's not vomiting, okay? Here is the next question over here. You can pause me as you need to. I'll do A and B first right here. Here's A. Look at that. Here's B, right here, all the way through. Hi, all the way through, all the way through. Here's B. Here is part C, which asks you for the second derivative, and here's where I took some liberties and made my life easier. The second, it asked you to find the second derivative at this point x equals -1 and 1. But interestingly, look over here. When you find the second derivative, you see the second derivative is in terms of dy and dx here. Now, I could go ahead and put dy dx into those expressions by, picking this up and pasting it in here. I could do that, but I don't need to, because at the end of the day, I just want to know what the second derivative is at this point, -1, 1, which means I know I'd be plugging in -1, 1 into dy dx. And in part A, I already found it was 1/4. So look over here. The second derivative at this point, -1, 1, is going to be dy dx at -1, 1, which is 1/4. And then I plugged in here -1 and 1, right? Into x and y, and I got these numbers. And this is part C. I don't have to deal with this. I don't feel like multiplying fractions. Just leave it right there. Leave it alone. Dr. Roble wants to say hi. Say hi, Dr. Roble. Hello! Okay, here's the next question. Right here. Notice, oh, you don't need me 6? It's canceled? Woo! No! Softball! Yay! This question looks vaguely familiar, but anyway. Here is k of x, and here's me finding k prime of x. K prime of 3. Looking in the table, looking in the table. That's the slope. And I had to find k of 3, right? Because that would be the point of tangency. Slope, point of tan, tangent line. B, h is g over f. here's me saying H is G over F. H prime quotient rule. And then here, boys and girls, just use a table. Yeah? I think you get the gist. You get the gist. Last question. Okay, I know one of you is going to scream, but you can't do this one yet, right? You can't do part B. Write an equation for the line tangent. Here's dy dx at 1, 0. Look how clear my writing is. This is saying dy dx at 1, 0. Gary, you're here! Yay! Because I don't have to cover for Dr. Roble because the softball game was canceled. I sent you an email. You obviously didn't check it.
I mean, I just got out of class.
Oh.
So.
Gary is saying hi. This is so weird. Gary is saying hi to this class, even though he's in a different section. Do you want to say hi?
Not really.
I'm giving a screencast to your BC Part 1 class, but it's not your class. But it's kind of like you're saying hi to yourself, which is weird. dy dx at 1, 0, all I'm doing is just plugging in 1, 0 here. Slope. Tangent line right here because the point is 1, 0. And then f of 1.2, the question said, you can stay. We're doing your schedule, right? Yeah, you can stay. I'm almost done. It says, use the tangent line to approximate the y value when x equals 1.2. So the f of 1.2 means, what is the y value when x equals 1.2? But use the tangent line to approximate it. So the y value when x equals 1.2 on the function is approximately the y value when x equals 1.2 on the tangent line. See how these are different y values, everyone? The y value on the tangent line, y value in the function. This is approximately equal to, and here's the y value in the tangent line, so f of 1.2 is approximately negative 0.6. Okay, and again, you can't do part B yet. Goodbye, TIC/BC Part 1.